In this lecture series, we've had a chance to look at a couple different components of websites. We've looked at HTML, the language for designing the content of a website, and how that creates a tree structure or document object model. We've also looked at CSS or cascading style sheets and looked at how that enables us to provide aesthetics or a graphic presentation to our HTML. We've thought a little bit about responsive design and what a ubiquitous computing world might look like in terms of responsiveness. And then we looked at how we could specifically drill down on screen size and orientation to deal with one way of making a responsive website. We recognized in the previous lecture about responsive web design that leveraging a library to help us do a grid-based system of web design was a way of giving us a lot of power to write one code base that would work across a lot of different screen sizes and orientations. But that came with the constraint of using that particular visual language in order to design our website. In this lecture, what I'd like to do is talk a little bit more about that responsive web design framework called Bootstrap. My name is Professor J Patterson. The key point from this lecture is to give you an overview of Bootstrap, currently at version 5. It is a framework for implementing responsive designs very rapidly. The basics of Bootstrap start with HTML, and the way in which you style your document begins with something called the container. The container is the most basic layout element in Bootstrap, and it's required in order to implement the grid system. As part of the styling of a container, you get the benefits of the grids, the columns, the padding that separates the columns, the spacing, and sometimes it centers the content that's within it. There are two basic styles of containers. One is a fixed width container that doesn't vary the size of the container based on, doesn't change fluidly. It has particular steps at which it will draw the container at different sizes as the screen size changes, in contrast to a fluid width container, which will always maximize that container across the entire width of the screen size. Two different approaches that deal with changes in screen size, and we'll show you an example of this in a second. So the two containers can be visualized in this way. Imagine that these are both screenshots of a web browser with the content that's within them, the content being the blue, purple, and yellow sections of the website. The top is rendered as a container. In order to do this, we're going to create a section of our HTML that is contained within a div tag. A div tag is an abstract tag. It doesn't have any styling or particular purpose associated with it. It's just a container that enables us to group different elements together and perhaps to apply some sort of class to it. In this case, we're going to take this div tag and give it the class container, and everything within it will be styled by the Bootstrap language. When we use container and we have a particular web size like we have right here, the contents within that container will be made as large as the step allows. The next step, the next width that we would draw this container, that we would draw this content in, would be too large to fit within this web window. And so the Bootstrap styling doesn't allow the container to grow larger unless the entire window were to grow larger. In the second case, we have a div whose class is container-fluid. And in this case, the way that Bootstrap styles this content is it always expands smoothly the content to fill the width of the website regardless of how big it is. So you can see that even though this might be in between two device sizes, the content fills up the entire width. The two basic building blocks of our grid system are container and container fluid. Bootstrap has this idea of different classes of devices. It gives them particular names and has particular sizes or breakpoints that's associated with them. It's possible to get into the Bootstrap guts and change this if you need to, but out of the box, this is what you get. You get extra small devices. These are phones that are in portrait orientation. We have small devices, which are phones that are in landscape orientation. And generally, the difference between this is anything between 1 and 575 pixels is considered extra small as a width. And anything that's between 576 and 767 is considered a small device. Our medium devices, for example tablets, are anything that ranges from 768 pixels to 991 pixels. Our large devices, a desktop computer for example, are anything from 992 pixels to 1199 pixels. We have extra large screens that are greater than 1200 pixels but less than 1400. And then finally, Bootstrap 5 introduced extra large devices, or really large screens, anything that's greater than 1400 pixels. Associated with each one of these categories of device sizes is a small two-letter acronym, EX, SM, MD, LG, XL, and XXL, or I guess in the last case it's a three-letter acronym. These are sometimes added to our class identifiers later on in order to identify different behaviors that we want. For now, I'll just have you note that they exist, and we'll bring them back in a future slide in order to explain how we're going to use them. When we have our outer container, the next level in our grid design is called a row. Rows are placed within containers. Rows then are split into columns. And finally, content is put into those columns. Think about it a little bit like a magazine design. You can think about how all the content in a magazine is in columns, and often the columns are in rows as well. The main thing that we get from a responsive design like this is that our columns will stack as the device size changes, according to the way that we specify. So we can see that in this first screenshot, we have 3 equal-sized columns inside one row. That one row is inside one container. When the device size is large enough, each of the content for those columns, the text, one of 3 columns, is laid out complete, with the complete distance in one sentence. As the screen size shifts, the columns remain equidistant, but the content within them wraps to form more of a paragraph presentation. But once the size of the device gets smaller yet, it crosses over one of our breakpoints, and those 3 equal-sized columns are no longer displayed horizontally next to each other. Instead, they're displayed stacked on top of each other. This is still considered one row with 3 columns, but those 3 columns have stacked on top of each other to accommodate a small device size. Let's start by looking at our container and our container fluid and look to see how they vary based on our size of our device. So here's a snippet of the HTML that I'm going to show you. So remember that in our grid system we have a container, and within our container are rows, within our rows are columns, and within our columns are our content. So to display equal width columns, we might have the HTML shown here. This is just a subset of that. Doesn't include the boilerplate for Bootstrap. On the leftmost side, we have an outer class of a container. You can see both of these examples have 2 rows that are within the outer container. The left example is a container, and the right example is a container fluid. The first row has 2 columns, West Coast and East Coast. Actually, the first row in both cases have 2 columns, West Coast and East Coast. And the second row have 3 columns, California, Texas, and Virginia. Notice that the way that we declare that something is a container or a row or a column is through a class name, applied, in this case, to divs. So we have divs that are transformed into containers, rows, and columns by applying a class to them. In this case, each one of our columns is designed to be equal width. That's indicated by the fact that we're using the class name COL with nothing after it. That's telling the grid system, please make all the columns that are next to each other in this portion of the HTML tree to be equal width. Now, in order to see these things in the rendering that I'm about to show you, I've also put an inline style statement at the top of the document. And you can see that I've specified that for any divs that are of class COL, I want the browser to render them with a black border around them. That's just so that we can see where the extent of the div and the columns go. All right, let's take a look at what this looks like. If we just render it at one particular size, the same size, you can see that the fixed width column, the one on the top, is rendering West Coast, East Coast, California, Texas, and Virginia. They're equal-sized columns. The first one is equal-sized 2 columns within a row, and the second row is equal-sized 3 columns within the row. What's different between the top and the bottom is the container type. The top one is a container with fixed stepped widths, and the bottom one is a container fluid that's going to expand to include the entire width of the device. Now, in a static presentation like this, it might not be clear how those two containers are functioning differently. But when we animate it, you'll see how the stepping behavior causes the fixed width container to only render at specific sizes based on the width of the device. Let's take a look at that. So this is an animation where I'm going to change the size of the fixed width container first. As the screen grows lower, you'll see the stepping drops down into fixed width, but different fixed widths at different sizes of the container. In contrast to the fluid container, which smoothly scales the content so that the rows always have columns of the same width, regardless of the size of the window. Different sorts of effects depending on what kind of aesthetic, presentation you want to offer. All right, so that was columns that have the same size associated with them. Now what I would like to do is show you how you can have one column that explicitly spans multiple columns. So in the previous one we said, hey, please make them equal sized. In this case, what I'm going to do is I'm going to show you several different rows. So the left screen grab here is one row, the middle one is 2 rows, and the third one is 3 rows, but they're all going to be within the same container. You can see that in the left side, we've said, hey, please make this row consisting of 1, 2, 3, 4, 5, 6 columns, and then 7 columns, 6 that are column -1 and 1 that's column -6. You can see that we've added to this class name the -1 or the -6. And what that means is that we want the content of this column to span one grid column. So each one of the first 6 columns is going to span one grid column, but the last one is going to span 6 grid columns. In our second row, we're going to ask the first content, the first column, to span 2, then 6, then 2, and then 2. Now our grid system is based on a 12-column system, 12-column system. And so in any one of our rows, if we're going to specify how many columns we want our content to span, we've got to make sure that they add up to 12. And I've done that in each case here. So the leftmost one, we have 6 1 columns and 1 6, adding up to 12. In the top of our second screen grab here, we have a 2, a 6, a 2, and a 2, adding up to 12. Down below that, we have 3, 2, 4, and 3, adding up to 12. On the right side, in our fourth column, we have 8 and 4, adding up to 12. The fifth column, we have 1, 5, and 6, adding up to 12. And in the final row, we have one column content that spans the entire width of all of our columns. So let's see what this looks like as we change the screen size. We're going to see that the size of the columns compress, but our content still spans the number of columns that we've indicated. All right, so now when we start with a wide screen, our columns are going to be wide. And as we shrink the size of our screen, our columns are going to get smaller, but our content is still going to span the same number. This is a fluid width container, so all the sizes are going to span fluidly instead of going through breakpoints. Content, in this case, can span multiple columns. All right. Now what we're going to do is we're going to add some breakpoints to those particular column sizes. And what these breakpoints are size classes that are appended to our column class. And what it instructs the grid system to do is when our screen gets too small, we're going to ask Bootstrap to stack those columns instead of showing them side by side. So let's take a look at what the different divs look like in this case. So on the leftmost side, we're not adding a size class. We're just keeping it as column -1. And that means that no matter what the size of our window is, each one of those content columns is going to span one column. In the second case, we're saying we're going to have 6 different columns which span 2 of our grid columns each. And we want them to span 2 of our grid columns each until we hit the breakpoint for a small device. When our screen size is smaller than a small device, we want those to stack. The third column here, we have 4 columns in our HTML, each of them spanning 3 columns in our grid system that are going to stack on top of each other once we cross over the medium breakpoint. Then we have 3 columns spanning 4 grid columns each that will stack when we cross our large breakpoint. 2 columns spanning 6 grid columns each that will stack when we cross our extra large device. and then one grid column that's 12 wide that it says we're going to stack at an extra large breakpoint, but since we only have one column, we won't notice anything stacking. All right, let's take a look at what this looks like as we animate. So as we animate this, we're going to start with all of our columns laid out side by side the way we asked for them to be. For example, our 6th row, second from the bottom, will have 6 different grid columns covered by 2 content columns. As we shrink the size of our width, though, the width of our screen, though, we ask that when we cross the extra large breakpoint, that we'd like those 6 columns to stack. And I designed it in such a way that as we get smaller and smaller and smaller, each row is going to stack from the bottom up as we cross the different grid points. But the top row will never stack because we didn't give a size class. Our 6's collapsed. As we cross our next breakpoint, our 4's collapsed. Next breakpoints, our 3's collapsed into stack design, and then our 2's collapsed into stack design. And since we didn't put a breakpoint on our 1's, they never stacked. And as we make our screen larger, the reverse effect happens as well. By using a clever combination of stacking instructions as well as grid column spanning instructions, we can get a very complicated responsive design that looks different in very specific ways depending on the width of the device that our user is viewing our column in. Now remember, even though I enjoy showing this as a dynamic changing effect, most of the time the way that your user is going to experience your website is through one particular fixed size. So the key here is not to focus on how it changes over time, but to look at how it presents at different particular sizes based on the size of the device that the user is going to be looking at it with. All right, so that's the key thing that I want to introduce about Bootstrap, is the way it provides responsive design, one code base that addresses multiple different device sizes. But Bootstrap also does quite a bit of other things. For example, by default, when you include the Bootstrap CSS, the default styling of all of your content is going to be different. For example, your headings are all different. They are a sans serif font instead of the Times New Roman font. And so out of the box, you get a much more modern, clean presentation for the tags that maybe you were using already. For example, H1, H2, H3, H4, H5. You get a clean presentation that is restyled from the default. Likewise, your outline bullet points are restructured as well. The spacing is adjusted a little bit. Top margins are adjusted. The nesting is a little bit better. The font size is a little bit better as well. Padding makes it a little bit cleaner. I guess the graphic designers have very strong opinions about the way these things are styled, and Bootstrap doesn't shy away from having a very particular aesthetic approach to the way the content should be presented. So if this isn't your preferred way in which it looks, you can change those things in Bootstrap if you get into the details to adjust particular kinds of aesthetic presentations. Finally, a lot of the widgets that come with HTML have been adjusted as well. For example, all of these different form widgets are adjusted. In particular, look at the range button there. File choosers, checkboxes, drop-down lists all have a particular kind of styling that looks cleaner and much more modern than the default styling, including a bunch of different things like date pickers and buttons and color pickers, etc. The last thing that I want to sort of dig into a little bit is the way in which Bootstrap supports responsive images. And so these are images that change their size based on the size of the device that you're working with. This is just really great because previously you really didn't get this much, you didn't get clean responsiveness with images on different sizes of devices. And you had to do a lot of workarounds to make sure that your images were being presented in ways that were legible. The way that you do this within the context of Bootstrap is, in addition to the normal HTML for an image, IMG, you include the class image-fluid. And what this is going to do is instruct the styling of that image to change its size based on the container that it's within. So I'm going to show you an example of some collapsing stackable columns in which I'm putting my personal logo in the last column in each case. And although it's really subtle, there's a really nice, smooth scaling of the images that's going to happen as the columns get smaller and smaller. And then when the columns stack and there becomes much more width, the size of the image is going to grow to fill the space that's available, as I've indicated that I want to have happen in the HTML. So this is the basic screenshot. I'm going to shrink the size of this window, and you're not even really going to notice that the images are getting smaller unless you're really tuned into it, because it happens so naturally. And then when they stack, you'll see it get larger. So here we go. Let's animate it. Right now, the images are getting smaller. They're scaling as the little grid space has less and less space for it to be visible. Smaller the space, the smaller the image. And then when the stacking occurs, the empty columns stack into nothing, and the images get resized to fill the space that's available in the new stacked column. This smooth scaling of images is really, when this was introduced, it was really a big deal in terms of web design. Smooth, responsive image restyling for the different sizes of the devices. There we go, back to the full size. So Bootstrap offers lots of other components as well. For example, a lot of support for nav bars, the bar at the top that has things like home and features, pricing, really nice ways of collapsing those things and to keep them in the top of your website even as you're scrolling content. Some options for buttons, both filled in buttons as well as outline buttons. Nice feedback for you. As you click on them, you get a little bit of response. Things like progress bars that are helpful as you give users feedback about the progress of some kind of event. These and many other kinds of components are available with lots and lots of examples and template code available for you on the Bootstrap website. Lots of templates that take all of these components together and show you some particular design. So here's a bunch of different templates from the Bootstrap website that show you how you can put all these components together to create some basic responsive designs. So let me pull one out. This is the album template. And I'm just going to animate this to show you how out of the box this template code collapses and uses the responsiveness in order to create different kinds of effects for different size devices. Now, while you can click on all these things and you can get some functionality, this is just a template, so there's no functionality built into it. That would require putting some JavaScript into this document as well, which in this lecture series we haven't covered yet. But you can see that you get a really full-featured website from this template code just to get things up and running, which is kind of the whole point, to get basic websites with responsive design up and running quickly. So to summarize, the key point here is that Bootstrap is a framework for implementing responsive designs very rapidly. It provides a lot of powerful CSS rules that you can leverage in order to get really nice, clean designs quickly. I'm not a particularly strong graphic designer, so this kind of tool is really helpful for me when I need to get something that's presentable but get it done quickly. The alternative is perhaps using a different kind of framework besides Bootstrap, and there are other frameworks out there as well. Perhaps one of those would suit you better. But the idea of manually creating all these CSS rules to develop a grid-based system or some other design language in order to make websites up and operational quickly is really kind of a foolish pursuit, because these grid-based systems have a lot of very talented developers who have been working very hard to get a consistent system working. That has been, the frameworks have been evolving with the web standards as well. So I highly recommend using Bootstrap or something like it in order to make clean, responsive web designs quickly. Thank you for your attention.